Hello everyone, a very warm welcome to all of you on the platform of Exampore. I am Sanjay Singh Tomar, your maths mentor, and I welcome you all in this very important session, guys. What we have planned for you based on quadrilaterals. I welcome you all in this very important session, guys. What we have planned for you based on quadrilaterals. So do join me, and once you join, please do not forget to let me know by your comments as well. Hello Ram, Kashi Vignesh, Vanakkam. Harika, very good afternoon. Very good afternoon. Jivita, Shrivani, very good afternoon. Okay. So, good afternoon. Namaste. Vanakkam to all the dear friends, guys. Come on, do join. Then we are going to begin with the quadrilaterals today. And once you join, guys, please do not forget to let me know by your comments. And the next thing you should be doing is sharing the sessions with your friends as well across different YouTube, Telegram, or WhatsApp groups. Okay. So today we are going to begin with quadrilaterals. Then later in the session, I can discuss the homework of triangles as well. Then later in the session, I can discuss the homework of the triangles as well. Okay. So once you are ready, guys, please do type ready, sir. Once you are ready, please do type ready, sir. Yeah. Here it begins. This is, you know, about Exampore official app. Yeah. Such an amazing place to learn. Such an amazing place to learn. First question of the day. First question of the day. PQRS is a rectangle in which sides are given. T is the midpoint of RS. What is the area of triangle PTQ? What is the area of triangle PTQ? PQRS is a rectangle. PQRS is a rectangle in which side PQ and RS are given. In which side PQ and QR are given. T is the point of RS. T is the point of RS. Guys, it can be any point. It is not necessarily the midpoint. It can be any point. It can be any point. It is not necessary to be the midpoint. Yeah. Area of triangle PTQ. Area of triangle PTQ is half of area of rectangle. Is half of area of rectangle. T can be any point, guys, on the side SR. T can be any point on the opposite side. T can be any point on the opposite side. In all the cases, triangle of PTQ is going to be half of rectangle. What is the area of rectangle? Length into breadth. Length into breadth. Length into breadth. Which comes out to be 8 4 ja 32, 3 192. So T can be any point, guys. T can be any point on the rectangle opposite side. It will always remain the half of rectangle. It will always remain the half of rectangle. Yeah. E can be any point. Area of triangle ABE. Area of triangle ABE is half rectangle. Area of triangle ABE is half rectangle. Its derivation is also very easy. Its derivation is also very easy. If you will ask, I would be doing it for sure. If you would ask, guys, I would be doing it for sure. In the triangles, we have done a lot of derivations. Yeah, in the triangles, we have done a lot of derivations. Waiting for your answers. Waiting for your answers, guys. ABCD is a rectangle. P is a point inside the rectangle. P is a point inside the rectangle. AP known, PC known, DP known, APB known. What is the length of rectangle? Draw it systematically. Draw the figure systematically, guys. Step by step. ABCD is a rectangle. ABCD is a rectangle. ABCD is a rectangle. P is a point inside such that AP is 3. PC is 4 root 2. Very good. DP is 5. Very, very good. And angle APB. Where is B? Angle APB is 90. Angle APB is 90. If this is 90, guys, this is also 90. Cool. If this is 90, that is also 90. Cool. AP3, PC 4 root 2, DP 5, APB is 90. If APB is 90, then this is also 90. What is the length of rectangle? Means they are asking this point. They are asking this point. There is a property, guys. There is a property for rectangle. There is a property for rectangle. And the property says if P is any point inside rectangle, if P is any point inside rectangle, if P is any point inside rectangle, then what happens, guys? What happens? What happens? PA square plus PC square is equal to PB square plus PD square. Have you read it? Have you read it, guys? Yeah, I'm not saying it's a straight line. Okay, ठीक है, चलो. Then eliminate this point. Eliminate this point. Okay, I will not use it. Well done, well done, well done, Kashi. Well done, Kashi. Even I will not use it. Even I will not use it. Even I will not use it. ठीक है? चलो. PA square plus PC square is equal to PB square plus PD square if P is any point inside rectangle. PA is 3 ka square 9. PC is 4 root 2 ka square 16 2 ja 32. What is PB? PB we are not knowing. What is PD? PD is 5 ka square 25. Cool? Cool. If you take it this side, then it's 9 plus how much? 7. So PB is root 16 or PB is 4. PB is 4. In a right angle triangle, if base is 3, perpendicular is 4, then the hypotenuse is 5. Watch out. Watch out. Important. In rectangle, if P is any point inside it, then PA square plus PC square is equal to PB square plus PD square. In any rectangle, if P is a point inside, in any rectangle, if P is any point inside rectangle, then PA ka square plus PC ka square is equal to PB ka square plus PD ka square. Cool? Cool, guys? Come on, tell me. Come on, tell me, guys. Okay. I would be writing all these, guys. Once the rectangle is completed, I'm going to write all this, yeah? Okay. So make a note. Make a note for rectangle. Make a note for rectangle. Make a note for rectangle, guys. Assume a rectangle L into B. Assume a rectangle L into B. Length into breadth. Assume a rectangle length into breadth. Okay. So area is length into breadth. Perimeter is if this is L, this is also L. If this is B, this is also B. Twice of L plus B. Twice of L plus B. Okay. Twice of L plus B. What else? Then, in any rectangle, if P is the point, in any rectangle, if P is the point on the opposite side of AB, if P is the any point on the opposite side of, then area of triangle APB, area of triangle APB is half the rectangle, is half the rectangle ABCD, is half the rectangle ABCD. Okay. And similarly, if P is any point inside the rectangle, if P is any point inside the rectangle, then we can also make this property that PA square plus PC square, PA square plus PC square is equal to PB square plus PD square. Okay. So just remember these few things now. Just remember these few things now. Then we are going to discuss more. Then we are going to discuss more. Then we are going to discuss more. Square. Come on. Read it very carefully. Read it very carefully. ABCD is a square. ABCD is a square. Square is a figure in which all sides are equal. ABCD is a square. Square is a figure in which all sides are equal. Okay. A line segment DX cut BC at X. A line segment DX cut BC at X. Okay. Like this. And cuts the diagonal AC. And cuts the diagonal AC at O. Guys, square is a regular polygon. Square is a regular polygon. Regular polygons means the most symmetrical figure. All sides, all angles equal. All sides, all angles equal. Yeah. All sides, all angles equal. We all know it. If all sides, all angle are equal, here the diagonal is an angle bisector as well. Here diagonal is an angle bisector as well. As in equilateral triangle, you might remember, as in equilateral triangle, the altitude, the altitude, the height, the angle bisector, the median, all are same. So here as well, this diagonal is the angle bisector as well. This diagonal is the angle bisector as well. So 45, 45. Question is gone. Question is over. Hello, Bharat. Question is over, guys. It's over, my dear friends. Once you identified that diagonal is the angle bisector as well in a square, once you identified that diagonal is the angle bisector as well, it's over. COD is 105. COD is 105. So remaining is 75. Remaining is 75. This is 45. This is 75. 120. So this is 60. They are asking CXD. What they are asking? OXC. Yeah, they are asking OXC. 60. 60. They are asking OXC. This is O na? So OXC is 60. Clear to all, guys? Clear to all? Come on. Clear to all? In a square, diagonal is the angle bisector as well. In a square, diagonal is the angle bisector as well. Let's move on. What are the famous values of tan theta you have read? What are the famous values? What are the values of tan theta you know? 0, 1 by root 3, 1, root 3, infinite. Only these values of tan theta you know. Only these values of tan theta you know, or you can find out. Okay. ABCD is a square. ABCD is a square. ABCD is a square. Diagonals AC and BD intersects and meet at O. And meet at O. Diagonals meet at O. Okay. K be the point on the AB. K be the point on AB such that AO is equal to AB. AO is this much. So let the K is here. BO is this much. So let the KL is here. Figure is going to look like this. Figure is going to look like this. AO is this much, so I take K over here. BO is this much, so I take K over here. What is log? Log is angle theta. Obviously, it's not looking 0. Obviously, it's not looking 0. This would be the answer. However, we will find it out as well. However, we will find it out as well. Okay? You know, guys, in squares, diagonals are the angle bisectors as well. In squares, diagonals are the angle bisector as well. So, this is 45. Guys, after 45, how much angle is remaining? After 45, how much angle is remaining? 135. 135. If these two sides are equal, then angle opposite to them are also equal. So after 45, 135 is remaining. So 135 divided by 2, 67.5 is this angle. 67.5. Similarly, these two sides are equal as well. So again, these two angles would be equal. If this is 67.5, this is also 67.5. Total is 135. So remaining theta is 45. If this is 67.5, this is 67.5. 135 is the total, this is 45. So theta is 45. Tan 45 is 1. By the common sense as well, we can give the answer, which I have given. By the common sense as well, we can give the answer, yeah? What I told you initially. By the common sense as well, we can give the answer. Thank you, Kashi. Clear to all, guys? Clear to all? Absolutely perfect. Come on, tell me. Clear to all? Absolutely perfect. Come on, do tell. Do tell. Okay, great. Great. So what we have learned, guys, what we have learned so far in the squares, is there is any other question? Yeah, there is one more. Then we will write the things. Yeah. A new strategy today, guys. In the triangles, we followed a different strategy. I was first telling you the things, then making you do the questions. Today, I'm taking a different strategy. You know why? Because I believe that quadrilaterals problem solving does not require too much of theory. Because that is my belief. Triangles problem solving require a sound knowledge of theory. However, quadrilateral problem solving doesn't require too much of too much of theory. That's my personal belief. Kashi, now clear? ABCD is a square. ABCD is a square. ABCD is a square. F is the midpoint of AB. F is the midpoint of AB. E is a point on BC such that BE is half of what? BE is half 1 by 3 of BC. So if this is 1, Total is 3. Can I say this is 2? Okay. Guys, in any square, you know the sides are equal. In any square, you know the sides are equal. You know it, na? Obviously. So if this is 3, this is also 3. So FB is 3 by 2, this is also 3 by 2. Here, in squares, the sides are equal. In square, the sides are equal. So I need to apply this property that if you have taken this as 3, take this as also 3. Now, area of triangle FBE. Okay. Now guys, in area there is a multiplication. In area there is a multiplication. So I need to take K with it. In multiplication guys, I need to take K with it. That is called samajdari. Yeah. So area of this right angle triangle is half into perpendicular into base. Area of this triangle is 108. So 3 will simplify 36 times. So K square is 36 into 4, or you can say K is 6 into 2, 12. K is 6 into 2, 12. Find AC. Find AC. Find AC. This is 3K. This is 3K. So AC is, this is root 2 times of A, na? Diagonal is root 2 times of A. So root 2 times of 3K. So my answer is root 2 times of 3 into K, and K is 12. Cool and clear? Guys, cool and clear? Please do watch out. Please do watch out and do let me know once you are fully satisfied with it. And do let me know once you are fully satisfied with it. Perfect. Perfect. Now let's write down the things. Yeah. For a square, you know each and every side is equal, each and every angle is equal. A. 90, 90, 90, 90. 90, 90, 90, 90. Cool and okay. Then diagonal is the angle bisector. Diagonal is the angle bisector as well. Diagonal is the angle bisector as well. Okay. Diagonals are angle bisectors. Diagonals are angle bisectors as well. And they bisect each other as well. Yeah. Which happens in every parallelogram. Which happens in every parallelogram. They will always bisect each other. They will always bisect each other. But here they are angle bisectors as well. Here they are angle bisectors as well. Okay. Here they are angle bisectors as well. Area everyone know. Area everyone know. A square. And perimeter everyone know 4A. And perimeter everyone know 4A. What else? What else, bacha? Diagonals are angle bisector as well. Each and every side equal, each and every angle equal. Area A square, perimeter 4A. What can I tell you more, guys? What can I tell you? Obviously, this is not 90. Obviously, this is not 90 because if this is, yeah, this is also 90. 90, this is 90, then this is also 90. It's a purely symmetrical figure. It's a purely symmetrical figure. Yeah. If this is 90, this is also 90, 90, 90, 90, 90. If this is 90, this is also 90. Yeah. So, it like bisect at 90 degree. You can write bisects at 90. Anything else, guys? Anything else? Yeah. The diagonal is root 2a. The length of diagonal is root 2a. The length of diagonal is root 2 times of a. The length of diagonal is root 2 times of a. If this is a, this is a, this is a right angle triangle, this is root 2a. All done? All done, guys? All done? There was no such properties as we have discussed over there. However, these all four portions are equal. So PA square plus PB square plus PC square plus PD square is also going to be correct. Yeah, okay, that is also Kashi Vignesh. Kashi has made a valid point. Sir, make one more point. One more point that on joining the midpoints, there is a formation of one more square. Wow, Kashi, you initiated a good point. Let's have a good discussion over it. Let's have a good discussion over it. If you join the midpoints, there is a formation of one more square. If you join the midpoint of the square, there is a formation of a one more square. Can you establish the relation? Can you establish the relation, guys? Can you establish any of the relation between the sides of these two? Let's suppose the initial side is 2a. So this is a, this is a, this is a. This is a, this is a, this is a, this is a, this is a. If this is a, this is root 2a. So side for the bigger square is 2a, and side for the smaller square is root 2a. What is the ratio they are maintaining? They are maintaining the ratio of root 2 ratio 1. They are maintaining the ratio of root 2 ratio 1. Side of a bigger square and side of a small square are maintaining a ratio of root 2 ratio 1. Is it clear till here? Is it clear till here? That side of a bigger square, side of a smaller square, a bigger for 2a, smaller for root 2a. So they are maintaining a ratio of root 2 ratio 1. So if I talk about the area of these squares, area is side square. So they will maintain a ratio of 2 ratio 1. Wow, what a huge discussion. So if you initiate some point, that's going to be a win-win situation for you. Okay. So whenever you are drawing a square inside like this, whenever you are drawing any kind of a square inside it, the bigger triangle is going to have an area as double of the small triangle. The bigger square is going to have an area double of the small square. The bigger square is going to have an area double of the small square. Like I can initiate one more discussion over it. You will thoroughly enjoy it. Join the midpoints. There is a formation of a figure. Yeah. Now join these midpoints. There is a formation of one more square. Guys, what is the relation between the areas of these? What is the relation between the area of these? Yeah. What is the relation between the area of this? Yeah. Big, middle, small. big, middle, small. If small is going to be 1, then this middle is going to be 2, and then if middle is 2, then the big is 4. Agree? Agree, guys? Agree? If for small it is 1, then for the middle it is 2, and for the big it is 4. What is their sides ratios? What is their sides ratios, guys? What is their sides ratio? Take the under root. Under root 4, under root 2, under root 1. 2 ratio root 2, 1. Wow. Isn't it interesting? Isn't it interesting, guys? So, if you know the side of this, if you know the side of this, you can find out side of this. If you know this side, you can find out that side. Chalo. Everyone say thanks to Kashi Vignesh for initiating the point. Yeah. Okay, it's a. I was just kidding. Okay. Then Ram is initiating some point. Ram is initiating some point, but oh, Ram, I cannot take this today. Yeah, SI. It's a quadrilateral, pure quadrilateral class. You can ask me personally. Yeah, you can ask me personally. Let's move on. Okay. Nandri stands for thanks. Yeah. Nandri stands for thanks. Okay. Rhombus is the kind of tilted square. Yeah. Rhombus is a tilted square whose sides are equal, but angles are not equal. Whose sides are equal, but angles are not equal. AB is 4, ABC is 120. But rhombus and square and whatever they all are parallelogram. They all are, what do you say, parallelogram. So, if they are parallelogram, so parallelogram means these two sides parallel. If this is 120, this is 60. Yeah. These two are also parallel. If this is 120, this is 60. So, what you are saying that opposite angles are equal, bacha. What you are saying, guys, that in rhombus, opposite angles are equal. So, in rhombus, you will say, sir, all sides are equal. All sides are equal and opposite angles are equal. Opposite angles are equal. Cool. Cool, guys. In rhombus, opposite angles are equal and all sides are equal. What is the length of diagonal BD? Here also diagonal is the angle bisector. Here also diagonal is the angle bisector. So 120 is 60. 120 is 60. Can you feel an equilateral triangle over here? Can you feel an equilateral triangle over here? In rhombus, all sides are equal. 4, 4. It's an equilateral triangle, so diagonal is also 4. So diagonal is also 4. Diagonal is also 4. Here also diagonals are angle bisectors. Here also diagonals are angle bisectors. But since angles are different, two angles are different, so there would be two different values coming. There would be two different values coming. How many of you know the length of AC? How many of you know the length of AC? Bacha, how many of you know the length of AC? Diagonals are angle bisectors. Diagonals are angle bisector. 60 two equal parts, 30 each. This is 4, this is 4. I'm asking you this. How can you find out this? How can you find out this, guys? How can you find out this? By the sine rule, guys. By the sine rule. Sine rule. You will say, guys, sine 30 upon 4. Sine 30 upon 4 is equal to sine 1/420 upon question mark. So, sine 30 upon 4 is equal to sine 120 upon question mark. Okay? Sine 30 is 1 by root 3. Sorry, sine 30 is 1 by 2. 1 by 2. And sine 120, sine theta is sine 180 minus theta. Sine theta and sine 180 minus theta are equal. So 120 is equivalent to 60. 120 is equivalent to 60. So I am putting the value of sine 60 root 3 by 2. Question mark. So question mark is equal to 4 root 3. Is it perfect? Is it perfect? Come on, do tell me. Come on, do tell me, guys. Any issues, any worries whatsoever? Any issues, any worries whatsoever? Ram, very good. If you remember it, then it's very good. So what is the property I've used? That sine 120 is equal to sine 60. By the property of sine theta is equal to sine 180 minus theta. Clear, guys? Clear, guys? Okay. Very good. Keep it up. Well done. Let's move on from here as well. Let's move on from here as well. So quite a lot of things to note down, quite a lot of things to understand, quite a lot of things to practice, guys. So giving my best among the best, guys, to make it very fruitful, to make it very fruitful. Oh, here the circle is involved. Not bad. Not bad, guys. OABC is a rhombus. ABC lie on the circumference of the circle. So draw like this so that it can form a circle. Draw on the same side, then only it can form a figure which is looking like a rhombus. Yeah. Draw it on the same side only, guys. Then only it can form a circle which would be looking like a rhombus. If you draw it on the opposite side, then you cannot form a rhombus out of it. Okay. Rhombus means all sides equal. Rhombus means all side equal. So, bacha, this is R, this is R, this is R, this is all sides equal. If this is R, so this is also R, so all sides are R. And one of the diagonal is also R here. One of the diagonal is also R. Wow. So basically, by drawing this diagonal, we have break the rhombus into two equilateral triangles. By only drawing this diagonal, we have break the rhombus into two equilateral triangles. Area of one equilateral triangle is √3 by 4a square. So 2 equilateral triangle is 2 into √3 by 4 r square, which is equal to 6 √3. Gone. R square is 12. R square is 12. Find the area of the circle. Find the area of the circle. Pi r square. R square is known as 12. So 12 pi is the answer. Two equilateral triangles. It is about two equilateral triangles. Two equilateral triangles. The rhombus was nothing but two equilateral triangles. If you draw the rhombus like this, it is nothing but two equilateral triangles. Area of one equilateral triangle, √3 by 4a square. So 2, it is twice into √3 by 4a square. Can I keep it till here? Because after 50, there is a thing that not to initiate one more question after 50. So guys, I will meet you in the next session. With again such a quality, such a exciting content. Anything, guys? Anything which you want to ask me? Is it clear to all? Because this is radius. This is radius R. This is also radius R. For any rhombus, all sides are equal. So if this is R, this is R, this is also R, this is also R. This is the diagonal. And this is also the radius. So diagonal is also R. Two equilateral triangles. So area is 2 into √3 by 4 r square, 6 √3. Come on, do tell, guys. Nice questions. Thank you very much, Jeevita. Now clear, guys? Chalo. Let's discuss the homework. Homework 1. However, you don't give the answers, guys. I've seen it. है ना? You don't give the answers. I've seen it. Yeah. I'm expecting the answers in the comment. I have included the triangles questions as well today. But today we have not got the sufficient time. We will get the sufficient time. Then I'm going to discuss them for sure. Whenever I will get the sufficient time, I'm going to discuss them for sure. Homework 2. Okay. Homework 3. Homework 4. Homework 5. Homework 6. So they are also running in the pending, guys. Okay, these questions are in the pending with me. These questions, no issues. Yeah, Ram, that's so good to know. These questions are in the pending. Whenever I feel like, guys, I will discuss them all in a single day. Whenever I feel like, guys, I will discuss them all in a single day. The quadrilaterals, the triangles, everything I'm going to finish it in a day. Yeah, everything I'm going to finish in a day. So that was today's session. I hope you must have thoroughly enjoyed it. If you have not downloaded the Exampur app, please do download it, guys. It's loaded with extra features. It's loaded with a lot of extra features. Subject wise, topic wise, practice quizzes, live paid courses, then job alerts, admit card, exam date, previous year papers with solutions, then a lot of current affairs, daily, weekly, monthly, pre-practice quizzes, full length test, topic wise test classes, loaded with extra features. Yeah, loaded with extra features like your pizza. Thank you very much, Ram, Jivita, and Harika. This is the way to download it. This is the way to download it. Exampur, install it, open it, register it, and this. Yeah. So extra cheese, like extra cheese. Okay. So this, remember, guys, these were those questions. I have already included them. Yeah, but time got less. We will discuss them, guys. No issue. We will discuss them. We will discuss them for sure. So take care of yourself. Have a great time. See you in the next session. Take care of yourself. Have a great time. See you in the next session.